So the thing that I've learned from AngularJS days is make it really palatable, right? And solve a problem that nobody else has. Doing yet another framework in this state of a world would be a complete suicide, because like it's just a different syntax for the same thing, right? So you need to be solving a problem that the other ones cannot solve.
The following is my conversation with Miško Hevery, former creator of AngularJS and now CTO of Builder.io and creator of the Qwik framework. I often find that people with this level of seniority and accomplishment become jaded and imagine themselves above getting their hands dirty in code. Miško is the furthest you could possibly get from that, having left Google and immediately started work on the biggest problem he sees with the state of web development today, which is that most apps, most sites don't get 100 out of 100 on their Lighthouse scores. We talked about how Builder.io gives users far more flexibility than any other headless CMS, and then we go into the two main ways that Miško wants to change web performance forever: offloading third-party scripts with PartyTown, and then creating a resumable framework with Qwik. Finally, we close off with a TED Talk from Miško on metabolic health. Overall, I'm incredibly inspired by Miško's mission, where he wants to see a world with lighter websites and lighter bodies. I hope you enjoy these long-form conversations I'm trying to produce with amazing developers. I don't have a name for it, and I don't know what the plan is. I just know that I really enjoy it, and the feedback has been really great. I'm still figuring out the production process and trying to balance it with my other commitments, so any tips are welcome. If you like this, share it with a friend. If you have requests for other guests, tag them on social media. I'd like to basically make this a space where passionate builders and doers can talk about their craft and where things are going. So here's the interview. Basically, I try to start cold, assuming that people already know who you are. Essentially, you and I met at Zadar, and I've heard of you for the longest time. I heard you on a couple of podcasts, but I haven't been in the Angular world. And now you're no longer in the Angular world.
Yes, the child has graduated, it's out of college. It's on its own.
My favorite discovery about you actually is that you have nonstop dad jokes. We were walking home from like one of the dinners, and then you're just like going on nonstop. It was amazing.
Yes. Most people cringe, but I find that it helps break the ice.
It does.
And they're dad jokes, so they're completely innocent, so you don't have to worry. I also have a good collection of computer jokes that only computer programmers get.
Okay, hit me with one.
How do you measure functions?
How do I measure functions? I don't know. The boring answer is arity.
That's a good one. Yeah. In parameters.
Yeah, so for anyone listening, like our entire journey back was like that. It's just like the whole group just groaning. No, it's really good. Okay, well, it's really good to connect. I'm interested in what you're doing at Builder. You left Google to be CTO of Builder. I assumed that I knew what it was from the name. It actually is a headless CMS. And we can talk about that because I used to work in LFI and we used to be very good friends with all the headless CMSs. And then we can talk about Qwik. How's that?
Yeah, I can jump into that. Sorry, my voice is a little raspy. I just got over regular cold, like the regular cold still exists.
Yeah, conference cold, right? I don't know. I had it for a week, and yeah, I only just got over it.
Maybe it was from the conference. Maybe it wasn't from the other trip I made. Anyways, so let's talk about Builder. So Builder is what we call a headless visual CMS. I did not know any of that stuff, what it meant. So I'm going to break it down because I assume that the audience might not know either.
Yeah.
So CSMS means it's a content management system. What it means is that non-developers, like typically a marketing department, think like Gap. Gap needs to update if you're showing stuff on the screen, you can go to Everlane. Everlane is one of our customers.
Okay.
And so in Everlane case, the marketing department wants to change the content all the time, right? They want to change the sales, what things are on the top, what product that they want to feature, etc. And this is typically done through a content management system. And the way this is typically done is that it's like a glorified spreadsheet where the engineering department makes a content and then it gives essentially key value pairs to the marketing, so the marketing person can change the text, maybe the image. But if the developer didn't think that the marketing person might want to change the color or font size, then there's no hook for it, and the marketing person can't do that. Certainly, marketing person won't be able to add new columns, decide that this is better shown in 3 columns versus 2-column mode, or show a button or add additional text. None of that stuff is really possible in traditional content management systems. So this is where the visual part comes in. So Builder.io is fully visual, right? Drag and drop. You can edit whatever you want in the page. And the last bit is headless, meaning that it's running on the customer's infrastructure. We don't host the website. If we are hosted CMS, then it's relatively easy to make a drag and drop editor. But because we don't host it, it's not our infrastructure. It's actually quite a head scratcher. And the way we do this, which I think is pretty cool, is we have this open source technology called mitosis, which allows us to give one input to mitosis, and it can produce any output in terms of like whether you use Angular, React, Vue, Svelte, Solid. It doesn't matter what you use on the back end. We will generate a component for you. And because we're generating an actual component, it drops into the customer's backend infrastructure, right? And everything just works. Their server-side rendering works. Everything that the customer might have on the backend, it just works because it's a full-on regular component, whether it's Angular, React, or whatever the company might use. So that's the unique bit that nobody knows how to do. And it's also the bit that attracted me to Builder.io and joining them. And the reason for that is because it is really easy for them to create new technology. So one of the things we're going to talk about later is this thing called Qwik. What's super easy with Builder.io is that they can easily produce new output. So if you have a customer that already has their content, let's say on React or Angular, and they decided they want to move over to something different like Qwik, and we'll talk about why that might be a reason, it is super easy because with a push of a button, because we generate the content, we can generate components in a different technology.
Got it. It's interesting. Have you seen Tailwind?
So Tailwind is more of a CSS framework, if my understanding is correct, for building.
But they had to build something for doing this, essentially, like having different outputs. They have one central template format that outputs all these different frameworks.
So this is what mitosis would do, right? But mitosis can do this across all of them, not just Vue, React, right? Every single one. Like, I don't even know what the list is, but there's a huge list of possible outputs that mitosis can do.
Yeah, you have Liquid and JSON.
And there's more. I mean, these are the ones that you see over here.
Shopify.
Yeah, you can see pretty much everything's on the list here.
Figma. Ooh.
We can import from Figma, given some constraints, because it's not a one-to-one thing kind of a thing. Yeah. But we can import from Figma. So the idea is that people can design their site in Figma, provided that they follow certain sort of guidelines. We can actually import them and turn it into HTML and then serve it up, whether it's React or whatever. One of the things that's actually important, for example, for us is Liquid, right? Liquid is a templating system on Shopify, but it's a server-side templating system, and it cannot be done on the client side. So if you pre-render on Liquid, how do you get a component to bind to it on the client? Because you would need to have the same component, right? One of the things we can do is we can pre-render on the Liquid and then produce an equivalent React component on the client and then automatically bind to it on the client, right? So we can do these kinds of tricks, which are normally quite difficult.
So you went from building one framework to building all the frameworks.
Yeah, you can think of it that way. But my real thing, the real passion is that I want to get all sites to be 100 out of 100.
Yeah, okay.
On mobile, not on desktop. You know, a lot of people claim on the desktop they can get 100 out of 100. Mobile, that's the bar. So I want to figure out how to do this. And in order to do that, you really have to get super good at rendering these things. And it turns out that if you just make a blank page, a blank white page with nothing on it, and you add a Google Tag Manager, that alone puts you essentially on the cusp of 100 out of 100 on mobile. So that alone, that act alone, right, is kind of uses up all your time that you have for rendering. And so the question becomes like, how do we make this as fast as possible so you can get 100 out of 100 on mobile? And it's very little processing time that you get to have and still get to have 100. And so we do two things. One is we are introducing a new framework called Qwik. Yeah. I'm going to talk about Qwik a little later. But the other thing we're talking about is introducing this thing called PartyTown. Okay. And I absolutely love PartyTown. So the person behind PartyTown is Adam Bradley. You might know him from making the Ionic framework. The guy is absolutely a genius. And this is a perfect example of the cleverness of it all, right? So you have something like a Google Tag Manager that you want to install on your website. And that thing alone is going to eat up all of your CPU time. So you really would like to put it on a web worker. But the problem is you can't, because the web worker doesn't have DOM API. It doesn't have a URL bar. It doesn't have just about everything that the Google Tag Manager wants to do, right? Google Tag Manager wants to insert a tracking pixel on your screen. It wants to register a listener to the URL changes. It wants to set up listeners for your mouse movements, for the clicks, all kinds of stuff. So running it on a web worker becomes a problem. And so the clever bit of geniusness that Adam came up with is that, well, what you really want is you want to proxy the APIs on the main thread into the web worker thread. And you can proxy them through, we have these objects called proxies. The problem is that the code on a web worker expects everything to be synchronous. And our communication channel between the main thread and the web worker thread is async. And so the question becomes like, well, how do you solve this particular problem? And it turns out there is a solution to this problem. And the solution is that you can make a XML HTTP request, which is synchronous on a web worker. And then you can intercept the request using a service worker. And then service worker can talk to the main thread, figure out what exactly that you want to do. So for example, let's say you want to set up you want to know the bounding rectangle of some div. The web worker thread can make that request, encode that request inside of a XML HTTP request, which goes to the service worker talks to the main thread figures out what the rectangle box is, and then sends the information back to the web worker thread, which then doesn't notice anything special. As far as it's concerned, it's just executing stuff synchronously. So you're laughing, right? Because this is hilarious.
Wait, so I'm one of those. Okay, you're a little bit ahead of me now. I'm one of those people. I've never used web workers or service workers, right? Can we talk a little bit about the difference, and like, are they supposed to be used like that?
So we did these two because they are supported just on the most browsers.
Yeah.
There's a different way of making synchronous call, and that is through something called Atomics. But Atomics is not available on all browsers yet.
Yeah.
So web worker is basically just another thread that you have in the browser. However, that thread doesn't have access to the DOM. So all DOM APIs are kind of gone from there. So you can do a lot of CPU intensive things over there, but the limited abilities. And this is what PartyTown solves, is it proxies all of the API from the main thread into the web worker thread.
Yeah.
Now, service worker is kind of a same thing, but the difference is that a service worker can watch HTTP requests go by and it can intercept them. And so think of it as almost like a mini web server in your browser. And so what the service worker does over here is it intercepts the request that the web worker makes, because that's the only way we know how to make a blocking call.
This is the one that we use for caching in like Create React app and stuff like that.
Yeah.
Okay.
And then because we can make a blocking call out of a web worker, the service worker can use the blockiness of it to make a synchronous call to the main thread and get all the information that you need.
That's pretty smart. Is there any relation to, I know that I think either Jason Miller or Surma did a worker library that was supposed to make it easier to integrate. Are you aware of that kind of stuff?
I think all of these worker libraries are in heart, they're asynchronous, right? And that's what prevents us from using it, right? Because the code as written assumes full synchronicity. And that is the bit that's different, right? That's the thing that allows us to take code as is and just execute it in a web worker. And so by doing that, we can take all of these expensive APIs, whether it's Google Tag Manager, Analytics, Service Hub, I think I'm mispronouncing it, I think. All of these libraries can now go to the main thread and they have zero impact on your Google PageSpeed score. And we actually talked to Chrome and we said like, hey, we can do this. Do you think this is cheating, right? Like, do you think that somehow we're just gaming the system? And the message was, no, because this actually makes the experience better for the user, right? Like the user will come to a website, and because now the main thread is the thing that is running faster and none of this stuff is blocking, you actually have a better experience for the user. The other thing we can do is we can actually throttle how fast the web worker will run, because when the web worker makes a request back to the main thread to say like, I want the bounding box, or I want to set up a tracking pixel or anything like that, we don't have to process it immediately. We can just say, well, process it at the next idle time. And so the end result is that you get really high priority for the main thread and then the analytics loads when there's nothing else to do. And this is exactly what you want, right? You want these secondary things to load at a lower priority and only be done when there's nothing else to do on the main thread.
That's amazing. Okay. All right. We have some demos here if we want to.
So let's look at the simple one, the element, right?
Element. Okay. Oops.
And what you see in the console log is this is just a simple test which performs synchronous operations. But what you see on the console log is that all these operations are intercepted by the service worker, right? And we can see what particular API the web worker is trying to do, and what the result is, what the return code is, and how to respond, and so on and so forth. And so through this, you can kind of observe what your third-party code does. By the way, the nice thing about this is also that because you can observe, you can see is if your third-party code, because we essentially trust them, right?
Yeah.
You fully trust this third-party code on your website, and who knows what this third-party code is doing.
Right.
So with this, you can see it and you can sandbox it. And you can, for example, say like, yeah, I know you're trying to read the cookie, but I'm not going to let you. I'm just going to return an empty cookie because I don't think it's your business to read them, you know, or any of those things we can do. So you can create a security sandbox around your third-party code that is kind of, as of right now, is just implicitly trusted. And you have a better control over it.
I could filter for it. And basically, I need HTTP calls, and then I need cookies, right? So
so in this case, there will be nothing because this is just showing off element API. But I think if you go to previous page, there is some cookie.
Before we go there, is there anything significant? And it says startup 254 milliseconds. What?
Yeah. So the thing to understand is that it is slower, right? We are making the Google Tag Manager slower to start up, right? So it's definitely not going to be as fast as if it was on a main thread. But it's a trade-off we're doing intentionally to say like, hey, we want to give the CPU time to a user so that the user has a better experience rather than eagerly try to load analytics at the very, very beginning and then ruining it for the user. So while in theory, you could run a React application in a web worker, it wouldn't be recommended because it would be running significantly slower.
Okay.
Because all of these HTTP requests, all these calls across the boundary would slow down.
Yeah.
So it is a trade-off.
So this is really for the kind of people who are working on sites that have a lot of third-party scripts for tracking.
All sites have third-party scripts, right? Like any kind of a site will have some kind of third-party, whether it's analytics, ads, or just something that keeps track of what kind of exceptions happen on the client and sends them back to the server, right?
So like
these
logging,
are standard things that people have on a website, and these are the standard things that are preventing you from getting 100 out of 100 on your score, right?
Okay, amazing.
So this is a way of unloading stuff from the main thread.
Got it. What's the API? I haven't seen the actual code of that. PartyTown. Okay, there's an adapter thingy, and then you stick it.
Yeah. So we those are just for React components. There is also vanilla if you scroll a little over.
Vanilla.
So the vanilla
you see how we have to prioritize React above vanilla. I know
that
must
even lower.
Be annoying.
This just shows you how you get the PartyTown going. Oh, here we go. Here we go. Right there. You're looking at it right there. So notice what happens. We ask you to take your third-party script, which if you go to Google Analytics, it tells you like, oh, take this script tag and just drop it inside of your head, right, or something like that. So what we do is we say like, do the same exact thing, except change the type to text/PartyTown. And that basically tells the browser, don't execute it. Instead, PartyTown will come later, read the stuff, ship it over to the web worker, and then do it over there.
So the only API is you just change this. That's it.
Yes. So you drop a PartyTown script into it, which is about 6 kilobytes. And then you go to all of the third-party places and just add type text equals PartyTown, and that ships them off to the other place.
So, it feels like Chrome should just build this in, like script type third party, right? And then just do it.
Yeah, I mean, we're having chats with them. You never know. Maybe if this shows up to be a very useful technique, it might be something that Chrome could consider. Well, for certainly, we need a better way of making synchronous calls from the web worker thread to the main thread, not from the main one to the web worker, right? That's clearly a bad idea.
Yeah. But
from the web worker to the main, it would be really nice to have a proper way of doing synchronous calls. Atomics might be the answer, And so it might be just as simple as getting all the browsers to adopt Atomics because it's a standard that already exists.
All right, let's see what is this thing? I've never heard of it.
Atomics is basically a shared memory array buffer between two threads.
Uh-huh.
And you can do atomic operations like locking and incrementing and things of that sort on it. And they can be done in a blocking way. So you can, for example, say like, increment this to 1 and wait until whatever result is 3 or something like that. So then you're giving a chance for the other thread to do its work.
I mean, this is like, so I'm writing assembly. Like,
it's not assembly, it's more, semaphore synchronization.
Okay, yeah, I see the locks and stuff, but this I can't just like throw in a third-party script here.
No. This is something that the PartyTown will use to get synchronous messaging across, right? Because currently it is kind of a hack that we create an XML HTTP request that is blocking that we intercept with a service worker. Like, that's just craziness, right? Okay. So Atomics would definitely be a nicer way to do this.
I think the goal is definitely very worthwhile. The underlying how you do it is a bit ugly, but like, who cares?
Yeah. So the goal is very simple, right? The goal is for us, we think we can have the best CMS if we can produce websites that are 100 out of 100 on mobile, right? Mm-hmm. That's the goal. Mm. And if you look at the current state of the world, and if you go to e-commerce websites, it's pretty dismal. Like, everybody gets like 20 something on their scores for their sites, right? Even Amazon, that has all the resources to spend, will only get 60 out of 100 on their score. Even Google website themselves gets only about 70 out of 100, right? So the state of the world is not very good. And I feel like we are in this Cold War in the sense that like everybody's website is equally bad, so nobody cares, right? But I'm hoping that if you can build a couple of websites that are just amazingly fast, then the world's going to be like, well, now I have to care, right? Because now it is different. And so now we're getting into the discussion of Qwik. So what is Qwik, and
yeah,
and why do we do this? So the basic idea behind Qwik, or rather, let me back up a second of why existing websites are slow. And so there's two reasons, right? One is third-party scripts, and we just discussed how we can solve this through PartyTown, right? We can move all the third-party scripts off. However, even if you move all the third-party scripts off, your problem is still going to be that the startup time of your website is going to be pretty slow. And the reason for that is because all websites ship everything twice. First, it's a server-side render HTML, right? And the page comes up quickly. And then it's static. So we need to register listeners. Well, how do we register listeners? Well, we download the whole site again, this time in the form of index, in the form of TypeScript or JavaScript, right?
Yeah.
And then we execute the whole site again, which is, by the way, the server just did that, right?
Yep.
And then we know where to put up listeners. And that causes, this is a perfect graphic for it, right? That causes double loading of everything. So we download everything once as HTML, and then we load everything again as JavaScript, and then we execute the whole thing again. So really, we're doing everything twice. So what I'm saying is that the current set of framework are replayable, meaning that in order for them to bootstrap on the client, they have to replay everything that the server literally just did, not even a second ago. And so Qwik is different in this sense because it is resumable. The big difference with Qwik is that the Qwik can send HTML across, and that's all. That's all it needs to send across. There's a little tiny bootstrapper, which is about 1 kilobyte and about 1 millisecond to run, which just sets up a global listener alert for the system. And no other code needs to be downloaded. And it can resume exactly where the server left off. So you need to have some form of way of serializing the state, getting the state to the client, having a way of deserializing the state. More importantly, there's an importance to be able to render components independently from each other, right? And this is a problem with a lot of frameworks, which is that even if you could delay the startup time of an application, the moment you click on something, React has to re-render the whole world, right? Not the re-render, that might be a wrong term, but it has to re-execute its diffing algorithm from the root, right? It has to build up the VDOM, it has to reconcile the VDOM, it has to do all these things starting at the root. And there's no real way to not make it from the root. And so that means that it has to download all the code. And so the big thing about Qwik is, how can we have individual components be woken up individually from each other? in any order, right? I mean,
Right.
people kind of talk about this in form of micro components or microservices on a client, right? This is what we want, but unlike the ultimate scale, where every component can act independently from everybody else.
Yeah, yeah. I think we should talk a little bit about that, because basically every single component is its own module and separately downloaded. So you're really using the, I think, multiplexing or whatever you call it of HTTP2, right? Like, you can just parallelize all those downloading, right? The main joke I made, because like I saw this opportunity and I was like, immediately, like, I know this will be the most controversial part, which is essentially the way you serialize is you put everything in HTML, right? Like that.
Yes.
So I immediately figured that out, and I knew it would stir up some controversy, but like also, like, I think the interesting, I mean, and we should talk a bit about this. Like, obviously, this is not handwritten by people, so people should not be that worried. But also, like, there are some legitimate concerns, right, about how, I think basically Dan Abramov was also you responded to Dan. So Dan said something like this. Okay, so it wasn't a direct response to Qwik, but Qwik serializes all state in HTML. And that's something that we considered for React Suspense. And he says, basically the question was, have you considered allowing server components to have serializable state using a Qwik mechanism? It's been proposed somewhere earlier. This doesn't work generally. State is in React is arbitrary. Payloads could get huge. Essentially, like, does this scale is the question. And he said that this was done before, and I went and looked it up, and he was like, yeah, that's actually what we used to do for web forms, right?
So if you look at React, the way React does things, and sorry, you want to pull this up? In one of the Dev2 talks, I actually talk about it, and it might be useful to kind of pull it out. Yeah, the one you're on right now, the answer to optimal fine-grained lazy loading. The point is that if you have a React component, React components take heavily closures, right? Closure is the bread and butter of React components, and they rely on closures everywhere. And it's beautiful. It's absolutely nice. I really like the mental model. However, it doesn't serialize, right? You can't take a closure and serialize it into HTML. So what Qwik is trying to do is it's trying to break this up into individual functions. Clearly, functions cannot be serialized, but functions can get a URL, a globally known URL, which can load this. So if you scroll a little lower, you will see a Qwik component. And the difference is that a Qwik component will have these declaration template, which points to a location to where this particular thing can be loaded. And if you scroll even further, it talks about how this particular thing can be served up in pieces to the client if you do this thing, right? So while it may be true that, like, oh, it's been tried before and we didn't do it, right? Have people really tried to solve every single one of these problems, right? And there is a huge myriad of them that Qwik is trying to solve and kind of get over. And so maybe I can show it to you as a demo of what I kind of have a to-do app working. So let's talk about this. One of the things, so by the way, the screenshot you have on your Twitter account, that is the old version of Qwik. After chatting with you and a bunch of other people at the conference, I really got inspired by lots of cool things. And this is a kind of the new version I'm working on, which has many of the issues fixed up and improved. So the thing I'm going to show you is standard to-do example, right? I mean, you've seen this millions of times before.
By the way, I did not know that. I think Eddie Osmani made this original to-do example.
Yes, he did. Yeah.
It's like the classic example for everybody.
Yeah, it's a classic example, right?
Amazing.
So remember, the goal for us is to serialize everything and send to the client in a form that the client can resume where the server left off, right? And then everything can be downloaded in pieces. So there's a lot of things to talk about. So let's start with how this works first, and then we can talk about how different pieces actually fit together. Okay. So, first thing you need to do is standard define your interface for an item and define your interface for to-dos, which is the collection of items, which contains a number of items completed in the current filter state and just a list of items, right? Like, so far, nothing special. Now, the special thing comes in that when you're declaring an object that you want to serialize, you will run it through this special function called QObject. And it's a marker function. It does a couple of things to an object, but you're just basically passing all the stuff in. And notice the individual items are QObjects as well. The reason I did it this way is because I want to serialize individual line items separately, because I know that I'm going to be passing the individual items into separate components individually, right? Mm-hmm. So what this basically says to the system is, like, there is a top level object which is this guy right here. And it can have rich state, but remember, it has to be JSON serializable. Therefore, it cannot have cyclical things inside of it. It has to be a tree. But inside of it, it can have other objects, and those can form cyclical things. So using the combination of those two, you can actually get cyclical graphs going inside of your application. But individually, each Q object doesn't have that. So that's a bit of a magic here. If I scroll over to the actual running application, what you will notice is these Q objects get serialized like right here. So for example, this one has some ID, and you notice it says completed 0, and then inside of it has individual items. And notice these items are actually IDs to other locations. So this ID ending in ZAB is actually pointing to this object right here, which has other things. So the whole thing gets serialized. And unlike the demo I showed in Zadar, I have moved all the serialized content at the end because I don't want to slow down the rendering of the top part. And so if you go, let's go back to our application. So if you have to-do app, the to-do app is declared in a slightly more verbose way than the one we declared in the React. But if we do it this way, then we can serialize the closures, right? The closures don't have that issue where it's non-serializable. By the way, the regular React way of doing things still works here. And you can do that. It's just they become permanently bound to their parent. They cannot be lazy loaded. So you can think of it as having two mental models here. You can have lightweight components, which are essentially the same as React components, or you can have Q components, which are slightly more heavyweight, but they get the benefit of having the whole thing decomposable and get lazy loadable and so on and so forth. So in this particular case, we're saying that there is a to-do app component, and the QRL is this magical marker function that tells the system that this content here needs to be lazy loaded. Or rather, let me rephrase it differently. It says the content here can be lazy loaded. The beauty of Qwik is that it allows you to put lazy loaded boundaries all throughout the system. And then an optimization phase later decides whether or not we should take advantage of these lazy loaded boundaries, right? In normal world, the developer has to put dynamic imports, and dynamic imports are asynchronous and they're a pain in the butt to work with, and it's not simple, right? So instead, what Qwik wants to do is say like, no, let's put dynamic imports everywhere, but do it in a way where the developer doesn't have to worry about it, and then let the tooling figure out later whether or not we should actually have a dynamic import at this location or not.
Yeah.
So even though this file, this to-do application is in a single file, the tooling will be able to break this file up into lots of small files and then decide in which order the things should be shipped to the client in order to get the best experience. You know, if there's a piece of code that never runs in the client, well, then put it at the bottom of the chunks, right? If there's a piece of code that is going to be most likely you're going to click on, then put it at the top. So anyway, so that's kind of a diatribe here, a bit off the rails here. But what this produces is a to-do, and it turns the code, right? This QRL function that says onRender, it gets turned into a URL. And this is what allows the build system to rearrange the code. And so this URL basically says, if you determine that to-do needs to be re-rendered, then you can go download this piece of code, and that will tell you how to re-render the to-do, right? You know, we are using a header and we're using main. Notice we're binding to-dos in there. So that looks like a regular binding, but the system has to do more work. So in this particular case, the main has to, see it has to-dos, it has to refer to a object. So notice this ID here matches the ID here. And this is basically how the system knows that this component here, because if you look over here, the main and footer, both of them want to know the to-dos, right? So both of these components need to have the same object. Oh. And so, yeah, exactly. So this main here, as well as the footer, they both have the same ID passed in here. And that's how the system knows, like, oh, right, if I wake you up, I have to make sure to provide you with the same exact ID. Now, not only that, there is also this particular thing, which is just a copy of it. But in this particular case, what it does is it lists all of the objects that could potentially affect the state of this component. And when you go and you modify one of these state objects, these objects actually keep track of each other, and they know which components need to be woken up and affected. So I think there's an example of it somewhere here later. Like right here, right? In here, it says, hey, if you, do a key up on the input right here, if I, type here over here something, then the key up runs, and then if enter runs, add a new item, which is just a function that, where is the function? Right here, which just pushes a new item into the list. And it sets my current state to text. Amazing. And so the system knows that in this particular case, in the header, this input right here has its own state right here. So let me refresh this again. This header has its own state, 1.8, whatever, right? Which if you look over here is right here, it's text blank, right? So if I type in here, I'm gonna change the state over here. And then if I set the state to blank, then the system knows, oh, that's object 187, whatever. Yeah. I can run a query. I can run document.querySelector_all, and I can say, give me all the Q objects. I don't remember how to do the selector for it. This star equals something like this. Anyways, there's a way to run a selector that will allow me to, whatever the code is, right? I'll run the selector, and this selector will then return this header back to me, saying, this is the object, or rather, this is the component that has interest registered into this object, which means because I've selected this thing, I have to find the QRender message and send the QRender message to download its template and re-render the object. And so what this allows you to do is have a completely distributed set of components that can be awoken only when a relative, appropriate data is changed, rather than having this world of like, well, the state has changed and I don't know who has a reference to what. So the only thing I can do is re-render the whole page. Well, that's kind of, doesn't help you, right? Because if you re-render the whole page, that means the whole code has to come here, right? So that's not helpful. We want to make sure that we only download the code that's actually needed. And so you need to have some mechanism by which like if I change this piece of code, if I change this object, which component needs to be awoken, right? And normally, like if you have Svelte does through subscription, this particular trick. The problem is subscriptions cannot be serialized into the DOM. And so we need a mechanism where the subscription information is actually DOM serializable, right? And this is what the Q object is, are the subscriptions that the individual components have to other things. And so the other thing I kind of want to point out is that we can then bind a complex objects, like in this case, it's a complicated state that we assigned to to-dos, yet it turned into a binding that's serializable into the DOM, right? So if I go back here, see, I'm jumping around. So we have our footer, so we have our main, the main is declared over here, standard JSX in here, where you want to iterate over a bunch of items.
Wait, what is a host? There's
a host. Okay, so one of the things we need to do is in React, when you have a component, the component is essentially hostless, or I would say it's a light component in the sense that it doesn't have a parent, right? And that is wonderful in many, many situations, but sometimes it isn't. The problem we have is that we need to have a component, we need to have a DOM element for each component that can be queried using querySelector_all, so that we can determine if there is a listener on it, or if there is a subscription on a particular object or anything of that. So we have this concept of a host element. And this is one ways in which the Qwik Q component is more heavyweight than the React component. You can still use React components if you want, you just don't get the benefits we talked about. And so a host element is a way of referring to the host element and adding an attribute to it, right? And saying like, oh, I want the host element to have a class main. And so if you go into, let's see, main, right? So it's supposed to be a class main, right? So it's the component that added it. So normally, the way you would do this normally in React is that the main would be a object that the JSX of the child React component, right? In this particular case, for a variety of reasons, we need to eagerly create this particular thing so that it's a placeholder for other things to go in. And so we need to do it eagerly, and then we need a way of like referring to it. So that's what host is.
Got it. Sorry for the
yeah, it's a little diatribe. Anyways, but this is how you create your items, right? And notice the way you got your items is you just got it from your props, and you can iterate over them, right? You can iterate and run the map and produce individual items. And for each item, you will pass in the key. So if you look at the item here, its prop says like, I am going to get an item in here. And my internal state is whether or not I am in editable state. So these are basically your props, and this is the component state in here. And on mount, we create our component state, say we're not in editable state. And then when the rendering runs, it has both the information about the item as well as about whether or not you are currently editing. And if you look at the UL, so here's one of our items that got generated. Notice that the item got passed in as a ID here, right? So if you go to the script at the bottom, let's see, this one ends in PT6. So we should be able to find, here we go. This is what actually is being passed in to that particular component. But notice there's a second object. Not only is there a PT6 object, there's also the secondary object. That's the state of the component. So if the state of the component, we're basically saying here is like, if this object changes or this object changes, I want to know about it and I need to be rendered. So these objects form a graph, right? Represents the state of your system. And then the Qwik provides a mechanism to serialize all this information into the DOM in such a way that we know which component is to be awoken at what time. So if I start typing here, one of the things you're going to see is that on first interaction, this script tag will disappear, because what actually happens is that when you interact with the system's like, I need to rehydrate myself, right? And so it goes to the script tag and reads it. So let me get the back over here. It reads the script tag and figures out, deserializes all these objects, takes this object, puts them inside of this object to build up the graph, and then goes back into the DOM tree and say like, okay, so I need to put this one over here, I need to put this one over here, this one over here, and so on and so forth. It puts all these objects back where they're supposed to be. And now your state is back in these components, but the components aren't present yet. They're not awoken, right? Because none of their mount or their render functions actually got called. And because the functions didn't get called, the code didn't have to get downloaded. So everything is super lazy, right? So when I go and I hit a key over here, the state gets deserialized, but the only piece of code that gets downloaded is right here. It is right this thing right here, nothing else.
Yeah,
right?
Can we show that in the network actually?
I would love to, but that part is mocked out right now.
Okay, all right.
In the old demo that I did for the conference, that one actually had it properly working.
Yeah.
But the feedback was that as a developer, there was a lot of things I had to do. And so I wanted to simplify it. So one of the things I did is I figured out a way, or rather I spoke with Adam, the same Adam that did PartyTown, and we figured out how to make the tooling smarter so that the developer doesn't have to do this. So what actually happens is that when you have the QRL over here, what actually happens is the code automatically gets refactored, and you will get a new function refactored like this. The system will put an export on it. And what gets placed in this location is a string that says something like chunk, ABC hash new local, right? Or something like that, right? So by doing this transformation, and that piece of code is not working yet, by doing this transformation, the system can then lazy load just this particular code, nothing else. But in order to do this transformation, we have to make sure that this code here doesn't have any closures, right? It cannot close over something and then keep that variable, because if it does, the whole thing doesn't work. And so the nice thing is that we can still write it in a natural form, but one of the constraints here is that you can't close over any variables. Now, there's no variables to close over, and the system is designed in such a way that it doesn't need it. Instead, things like props and state are explicitly passed into you, as well as to the handler as well. So you don't have a need to create these kinds of closures, but it is a constraint. And this is what allows the optimizer to go and rearrange your code base in a way where we can then determine what things are used. So in this particular case, we can, for example, determine that you're likely to go and interact with the input box, but you are very unlikely to actually call this on render, because this is the kind of the Chrome, the shell of the application. And once the shell of the application is loaded, you will never ever interact it, right? So what you can do is you can take all these imports and you can sort them, not alphabetically, you can sort them by the probability of usage. And then once you have them sorted by the probability of usage, you can tell the optimizer like, okay, take the first N ones so that I have a chunk that's about 20 kilobytes, because we think 20 kilobyte chunks are optimal.
Yeah.
Right. And then the system can be like, okay, let me add a whole bunch of them until I have 20 kilobytes. Let me add a nice chunk that until I have about 20 kilobytes. And I can do this chunking all the way on the end. And then the last chunk will probably end up with a bunch of stuff that never ever gets loaded. Right. But the problem is the current way we design applications, you can't do that. You just can't. Right. And so we have this mentality of like, we have frameworks that have amazing developer experience, but they set up the developer experience down the path of monolithic code base.
Yeah.
And any kind of lazy loading that the developer can add after the fact is just like kind of a kludgy workaround, right? And that's the thing that the Qwik solves. It says like, no, let me help you design an application that has still nice developer experience, but let me structure things in a way so that I can later rearrange things. Right? Let me keep you on this guide rails of like, make sure you do it in these ways. And so everything in the Qwik is set up in a way where it keeps you in these guide rails. And the result is a piece of code that the optimizer in the Qwik can rearrange, right? It can go and pull out this function. It can pull out this function. It can pull out all of these functions and turn them into top level functions that are exportable. And it can then tree shake the stuff that's not needed and produce chunks that can then be lazy loaded into your application.
Like 4 or 5 years ago, I think there was some, I think even at the Chrome Dev Summit or something like that, there was a effort to use Guest.js to basically use Google Analytics to optimize all this intelligent preloading or loading predictions. Is that how, I think I missed the part about how you pull in the statistics for optimizing.
Yeah, so the first thing to talk about, I think is important to understand, is that unless you can take your application and break it up into lots and lots and lots of chunks,
you can't do that, yeah.
There is nothing to talk about, right? If your application is one big chunk, there is nothing to talk about. You have to load the chunk, end of discussion.
Well, so the chunk was page level, and now you're doing component level, right? So they were saying we split it by page, and we can predict the next page. So
yes. So look at Amazon, right?
Yeah.
Most of this stuff, you can click on stuff and there's a menu system up here, and let's pick a random component here. Let me just go to something. Come on, just give me a detailed view of something. There we go. Most things here never had to be re-rendered. Like, for example, there's a component here. This component never ever changes. Nothing here will render. Nothing will render here. Yes, these are components and I can click on them and they update the UI over here. But if I'm interacting here, why am I downloading the menu system, right? Mm-hmm. And so the point is, if you have a page like this, there is huge number of components in here, but most of them either never update, or in my current path of interaction, I just don't need to update them, right? If I'm using the menu system, then I don't need to download this thing here. And if I'm interacting with my item, then I don't need the menu system. And not unless I put something out to cart, do I have to worry about my shopping cart.
Yeah.
Right. And this is the problem, is that we currently bundle the whole thing up as one giant monolithic chunk. And yes, there are ways to break this out, but they are not easy. And everybody knows how to do route level breakup, but like even on route level, it's not fine grained enough, right? And so the magic of Qwik is the magic of writing the code in this particular style is that for a typical size application, I can break up the application in literally thousands of chunks. Now, that's too much. We've gone way too far, right? These chunks are too small. We don't want that, right? But when I can break things up, it's easy for me to assemble bigger chunks out of it. But the opposite isn't true, right? If I have a big chunk and I want to break it, well, good luck. No amount of tooling is going to do this. As a matter of fact, The best AI system we have, which is right here in our brains, right? Even if you give it to the developer and say, go break this thing up, it's a head scratcher that takes like weeks of work, right? And so we are in this upside down world of like, build a humongous thing and then have this attitude of like, somehow tooling will solve it. Tooling can't solve this problem, right? You have to do it the other way around. You have to design a system which breaks into thousands of little chunks. And then the tooling can say, yeah, but that's too much. It's too fine-grained. And let me glue things together and put them together into bigger chunks. Because through experience, we know that an optimal chunk size is about 20 kilobytes, right? And so now the thing you want is to get a list, the order of which the chunks are used. And that's easy, right? If you're running your application, you can just keep statistics on how users interact with your application, and that statistics can be sent back to the server. And so what you can get back on the server is just a ordered list of the probability by which you're going to need individual chunks.
Got it.
And that sorted list is all you need to tell the optimizer, like, start at the top of the list, keep adding items until you get to a correct chunk size, then start a new chunk, right? And you keep doing this over and over and over again.
Okay.
Now, the reason I get excited about this and the reason I talk about it is because we completely ignore this problem, right? We have these amazing frameworks, whether it's Angular, React, Svelte, or whatever, that allow you to build these amazing sites. But at the end of the day, we all have horrible page speed scores because we're not thinking about it from the correct way. And the attitude for the longest time has been, the tooling will solve it later. And my argument here is, no, the tooling will not solve it later. If you make a mess of this code base, there's nothing the tooling can do.
Got it. Yeah. There's so many directions I could take that in. So first of all, the React term for this is a sufficiently smart compiler, which has been in the docs for like 4 or 5 years.
Yeah, it doesn't exist. I think it's a myth. That's my point. Like, you cannot make a sufficiently smart compiler.
So is there a compile step for this because of the QRL section?
There is. So right now it's actually running without compilation whatsoever. So one of the things I want to make sure that it runs both in a compiled and non-compiled state. And that's why it comes up with these bogus things like mock modules, etc. And I think if you go to the network step, it loads the mock module and it just re-exports it. And I can't really show you. But basically all of these things are kind of just in there. So currently this thing runs as a single monolithic application.
Okay.
But the way this thing would work is that, as I pointed out, every place that you see QRL is a hint to the compiler to go and extract this. The compiler literally will just take this, Control-Shift-R, extract like here, and then gives it a name, which would be, I don't know, header : key up, right? Yeah. And then it repeats the same exact thing over here. So Control-Shift-R, extract. This is a header on mount. I mistyped it.
It's okay. I get it.
Right. And the same thing here. Control C. There we go. Control-Shift-R.
What if I need to do like conditional loading? Because the compiler doesn't know which branch I need to go down.
Right. So I'll answer the question in a second. I just want to point out. So notice what ends up here. The header is super, super lightweight. There's nothing in here because these two things will get converted into these URLs, right?
Yeah.
And because of that, this header is permanently bound to the unrender of the to-do app, right? If you load a to-do app, you're also loading the header and a main and a footer. But the thing we've done over here is we made this super lightweight. And this is what allows the lazy loading to happen. Now, you're asking, well, what about other components? Easy. I mean, if you wanted to conditionally include the header, standard stuff, true, right? Now, the header itself will always be permanently bound into the onrender of the to-do app, right? However, because we did that trick where we extracted everything out of it, the header is super, super lightweight. It doesn't contain anything, right? So the only thing the header really contains, if you go in here, is what to do on mount. This URL is the only thing that's in there, and also this render, right? So these two URLs are the only thing that is contained inside of the header by itself. Okay. It's only when we decide to render the header do we go into the header and we say, okay, we're doing rendering. So what's your URL? And we look at this URL right here. We download the code. And so now the rendering pipeline has to be asynchronous. We download the code, and then we go and execute the content, and we basically fill in the content of the header. Now, in the process, we also realize, oh, we also have to download this piece of code. And this is where statistic would come together and would basically tell us that this URL and this URL always get downloaded together. And therefore, the optimizer will be smart enough to always put them together in the same file, in the same chunk. And, we will render the content.
Got it. Okay, so one small piece of API feedback / questions. You have a tag name. Is it optional there? I guess that's a hint to what to store the data.
Right. So right now it says to do right here. If I comment this out,
that's literal tag name. Okay, got it.
Right. It becomes just the div.
Yeah.
So the system doesn't care what the thing is. It needs a element. It could be any element. A div will do just fine.
Okay.
It's easier to kind of on the eyes if it actually says to do, right?
Yeah.
So that's the only reason for it.
Okay, got it. The bigger piece is, okay, so like a lot of HTTP requests, every time I make a request, or every time I interact with the app, I essentially need to do a whole new handshake, a whole new network transfer. There's some baseline wait for that, right? Chunking.
How to fix that? Yes.
Chunking helps. Is there a preload essentially? Is there like a programmatic, like say like, okay, and by the way, this is important for offline capable apps, right? Like let's just say like I'm going offline, like it's 5 things. I know I don't need it right now, but like as an app developer, I know I need it.
Yes. So we can totally do that. There's a web worker that will be set up, and the web worker will get a list of all the chunks, and the web worker will try to go and download and set up the caching for you in these chunks ahead of time. So when you interact, the only thing that the browser has to do is execute the code. Now, because these chunks are small, the execution code, we're not worried about it, right? In the case of like a typical framework that's replayable, the problem is that the first time you interact with this thing, you have this huge amount of code to download, parse, and execute, right? But this isn't the case here, because every interaction really only brings in the code that's strictly necessary for this interaction. So again, if we go to like the Amazon, right? If I hover over here, over these things, and it changes the image on the right side, the only code that gets downloaded and executed is the code for this. Now, it's already pre-downloaded because the web worker would go and pre-fetch it for you. Okay. So the only thing that the browser has to do is parse the code and execute the code for the on-hover callback that goes and updates this component's URL, right? That's it. No other code needs to be downloaded or present.
Yeah, got it. Anything else that we should cover about Qwik in general?
I feel like I have talked your ear off, and you have been such a good and gracious host. Happy to answer questions. I don't want to overwhelm people.
Yeah.
But I am super excited. As you can tell, I'm super excited about this.
I love it.
Because I think it's a fundamental shift about how you think about frameworks. Like if you look at all the existing frameworks, they're all arguing about like, I have a better DevX, I can do this better or that better, etc. Right? But fundamentally, they're about the same, like essentially the same bucket. They can all do about the same thing.
Yeah.
Qwik, I think it's a whole new ball game, because the Qwik thing is not about like, oh, I can render a component just like 50 other frameworks can do as well. The thing that Qwik has is I can do it. I can give you microservices for free. I can give you this micro component architecture for free, and I can produce a bundling. I am the sufficiently advanced compiler. Okay, let's put it this way. This thing that you thought you could have and solve for you doesn't exist unless you have the correct guidelines, right? So the thing with Qwik is that it is the thing that allows you to have a sufficiently smart compiler to give you this amazing times to interactivity, right? At the end of the day is there's nothing faster than downloading HTML for your website. I mean, that's the king, right?
Yeah.
So the reason why Qwik is fast is not because Qwik is clever in the way it runs JavaScript or anything of that sort. No, Qwik is fast because it doesn't have to do anything, right? When you come to a Qwik website, there is literally nothing to do, right? We're fast because we don't do anything.
Your baseline is like a 1 kilobyte like loader, right? That's
good. Yeah, 1 kilobyte loader. All the loader does is sets up a global listener, right? So let me go back. Sorry, let me share one more thing. Okay. So here is your input, right? So if you go to header, here's the input, right? The reason we know how to do something on it is because we serialize this thing called on:"key up, and there is a URL, right? So when this thing is first executed, nothing is done. Like this content shows up, that's it, we're done. And the only reason why we know to do something next is because when I do a key up here, the event bubbles up all the way to the root. At root, we have this quick loader, which registers the code base and figures out what to download and what to do next, right? That's the only reason why the whole thing works.
Yeah, yeah, that's amazing. I want to get your commentary on a couple more things that are related to this, which is, first of all, the islands architecture, also by Jason Miller. Have you come across it, talked to him about it, how Qwik compares?
I've read a bunch of things in this particular space. I don't think I read this specific one. I think there's a nice article that the React team has put out in this particular page as well. It is, I think the world has come to the same conclusion, which is that we have these replayable apps and it's a problem and we need to break them up. And so what's happening here is that basically they're saying like, let's create these islands that can be lazy loadable. And there's all these constraints that automatically come with these islands, right? And all have to do with like, how do you share data between them? And when do you know when to wake up these islands and so on and so forth, right? And this is great. Qwik takes this idea to the absolute extreme and says like, every component is an island. What do I have to do in order to make every component an island? I need a way of passing complex data into this component in a way that's serializable. So there's a whole architecture around how do you take the data and serialize it into the DOM. As we saw, you know, the most obvious version of it, which was the queue objects, right? But there's a lot more that I didn't cover. So all of these things have to be done and solved. We need a way of knowing when individual islands need to be awoken, right? Which I'm sure they're not even discussing over here because it's a problem that you run into later, right? Because if I interact with one item, so for example, a carousel in this particular thing, how do I know that I have to wake up a header or the sidebar or any other piece of the UI? Like I need to know this somehow. And you can say like, well, that's a developer's problem, but that doesn't actually solve anything, right? And this is what Qwik is good at, is that because it can serialize all these pieces into the DOM, it then knows who is aware of what data. And therefore it knows if a particular data changes, who do I have to wake up? And so this is absolutely a step in the right direction. Qwik is what happens when you take this and take it to an absolute extreme.
Yeah. So, okay, for those who haven't checked it out, the other two frameworks that are kind of in this vein are Elder.js in this felt ecosystem. By default, only HTML, 0 KBO.js, but then you call out which islands you want to implement, and then that hydrates into a felt component. So this does a bit of that partial hydration.
But again, you have to talk about like, well, how do I know when to do it? And if I wake it up, like, how do I set up listeners on it? And then those listeners, how do they know when to wake up other islands? Like all of these things are kind of glossed over in these particular things because, you know, people know that they have to go this direction, but they don't know what's waiting for them when they go further enough.
Yeah. So just pointing out like alternatives that other people are working on. And then one final question I think I have, something that React has sold people on is that registering event listeners is expensive. And that's why we have synthetic events. Is that true? Do you have a view on like synthetic events and whether or not we should have them?
Actually, I'm not sure what synthetic events are. Can you tell me more about it?
Okay, so instead of registering independent event listeners on every single component or tag, React only registers one root listener. And that's everything bubble up to that root.
Yeah, that's exactly what Qwik does. Yeah.
Oh, okay.
Now, the thing is, when you do that and you have a global listener, now you have a problem, which is like, how do I back reference and figure out which callback to call? Right?
Yeah.
So
exactly.
React needs to somehow walk this tree and figure out where is that actual closure. Like at the end of the day, I have to call a closure, right? So where is that closure that I need to call to do this? And the problem is these closures are not serializable, right? Whereas in the world of Qwik, we also have synthetic listeners. Where is my share button?
I should mention that synthetic events are primarily for cross-browser compatibility, but there's still the concept of event pooling in React, and there's still a concept of bubbling.
Right. So let's take this particular thing, right? So what happens is there's a global listener at the top, you do key up, it bubbles up, the global listener catches it, goes back up and says, okay, this is where it originated. It looks for on key up event. It finds a URL, and that URL points to this guy right here, right? This thing has amnesia, right? Like it just got awoken and has no idea what's going on, right? It's like, I call it amnesia, right? So one of the things that the QRL has to do is to recover the state. And this is something that happens back in the back without you thinking about it, right? So the QRL wakes up and says, okay, I have amnesia, I have no idea what's going on. Let me go recover the stuff. And let me go try to compute the state, get the props, everything I need to execute this function, right? Which is why when you look at this, you see the script that contains the state. When I first click on something, that script tag gets consumed. It disappears, right? Because that's when the system woken up with an amnesia and said, oh, wait, where's my stuff, right? And it goes look for it, finds all the pieces, and then determines that this component has this 2kz object, which is right here. And so it deserializes it and places it in the right location and gets it going. So this is very similar to synthetic events. The difference again is that we take it to the extreme of saying, on the end of the day, this is just function that is somewhere that I can lazy load and I need to execute and I have to restore the function state and then let it do its job.
Cool. Sorry for like the really random deep dive, but I feel like these are questions that people have when they compare it with what they know.
No, I think those are excellent questions.
Yeah.
And if I can leave one thing is that don't think of this stuff as yet another framework, right? We already have plenty of yet another frameworks out there. And I'm going to argue that they're pretty much the same in terms of the capabilities. This is not trying to be yet another framework. This is really trying to solve a set of problems that we are faced with every single day and we don't have good solutions for. This is really trying to solve this sufficiently advanced compiler, which I believe is not achievable unless you cooperate. And the reason it's not achievable again is like, imagine you go to the developer and you say, go put me a lazy loaded boundary over here. That person will spend weeks, right? And refactoring it. Maybe they want to even be able to succeed in this particular location, right? Because the whole thing needs to be rearranged, right? The compilers cannot possibly do this.
And I'll just observe that you can use React inside of Qwik. You're already using TSX and you can.
Yeah, one of the goals for me is I don't want to have to be responsible for writing widget library. And so I'm thinking super hard how I could just consume React widget libraries. And I think it's possible. There's a couple of caveats, but I think it's possible.
Yeah, I think that closer to Astro, but with a bit more fine-grained loading than Astro offers, which is pretty cool. You might want to check out Astro's data loading on the server side of things, which could be interesting. Okay, cool. I want to zoom out a little bit and spend a bit of time on Angular, and then we'll do your TED Talk. So a lot of the things that I hear about Angular are sort of second-party, third-party type of stuff. What did you learn from the adoption of Angular that you're bringing over to the adoption or rollout of Qwik?
That's a good question. It's a really good question. I love it. I think Angular was lucky in a sense that it was a framework where there were no other frameworks in a JavaScript ecosystem, right? And so in that sense, it was the first one. You know, what we had before Angular was
GWT.
Yes, which is not a framework. It's a transcompiler. We had jQuery, which is not a framework, but kind of a hacky way of modifying the DOM. And I don't mean this in a negative way. It's just not a framework. We had there's the Marionette and Backbone, right? Which was kind of framework-ish, but really only about how to track data. So it was really a subscription for data model rather than actually how to render things up. So in that sense, I think AngularJS defined its own category. And I think this is the reason why it was so successful, is because there was a need and the world needed this and recognized that it needed it. And so it just went after it. Since then, there's a bunch of other frameworks that came afterwards. All of them have unique ways of improving on this idea. And, React took the idea of functional and went crazy with it. And I think it's wonderful. Svelte took the idea of actually true reactive system where you have subscription things and you update only when it's necessary. And I think they did a great job. And there's many things in Svelte that I really, really like. Like all these frameworks have some amazing things in them. But at the end of the day, they're still solving the same problem, right? They're still in the same space and they're solving it in the same way. And specifically in the same way, I mean, like we're pretending we have a desktop application and we pretend that all the code is just available for us, and we're pretending that we can just like do whatever we want, right? When in reality, we're not a desktop application, we're a mobile application where the code isn't available to us. There is a cost to start up all this code. And so we have a new set of problems that we created. And the new set of problems that we have right now is how to start up the apps quickly. And I was just chatting with somebody from Airbnb, Elliot Sprehen was a good buddy. We actually worked with me on AngularJS days back in the day. And he was just saying how they spend many years trying to rearrange their homepage, because it's a React application, in such a way to make the startup tab fast. And what they essentially end up doing through a complicated set of hackeries is lazy loading the individual components over time, right? So they lazy load the first one first, and then get the other ones going, downloaded, that are below the fold when you have nothing to do, right? And so the solution is the same, that everybody knows what the solution is. Everybody's trying to do the solution, but the current set of frameworks are just fighting it tooth and nail. One way that they're fighting it tooth and nail is, for example, that the rendering pipeline is fully synchronous, right? In all the frameworks, when you say render, everything that you need to render better be around. Otherwise, bad things happen, right? And that means that all the code has to be around. And that means that there is no good way to just say, no, I just want to render this component. I don't need to render its children, and I don't need to render its parent. I just want to render the component in isolation. And existing frameworks don't know how to do this. The other thing that existing frameworks don't know how to do is, again, storing the state. Like, how do I store the state in it? So the thing that I've learned from AngularJS days is make it really palatable, right? And solve a problem that nobody else has. Doing yet another framework in this state of a world would be a complete suicide, because like, it's just a different syntax for the same thing, right? Yeah. So you need to be solving a problem that the other ones cannot solve. And I'm actually going to go on a limb and say, like, they cannot solve this. There is no way to add this kind of fine-grained lazy loading to Angular, React, Svelte, or any of these other technologies, because doing so would be such significant breaking changes that you would end up with a different framework, and the individual communities wouldn't stand for that. So there is no way for React to get these capabilities. There's no way for Angular to get those capabilities, and so on and so forth. That's good and bad, right? It is good because it creates a value that nobody else can provide. It is bad because it causes a rebreak. But hey, this is where Builder.io comes in, because Builder.io has mitosis, which allows us to consume one format and generate many other formats out of it. And this is why I think something like Builder.io and Qwik makes so much sense, right? Because Builder.io has lots of existing companies, lots of existing content, lots of need for speed. Qwik has the answer, but it requires migration. But with Builder.io, migration is trivial because, well, we just generate another output.
Got it. Yeah. Wow. I feel like basically we're missing a term for this, for what you're trying to do. You keep saying framework, but we don't have a better term for it. So I'm thinking like app loader, something light, something super light.
Yeah.
That emphasizes that you're not directly competing with the other frameworks because you can use them together.
When I first started Qwik, I actually wanted to use the React as the rendering engine. Turns out, for many reasons, that it's not possible. As I pointed out, that the fact that React wants to be fully synchronous kind of ruins your day in this particular department. But yeah, I really don't want to make another framework in that sense, right?
Yeah.
And this is why I'm reusing GSX and as much stuff as possible, which is, how do I do least amount of work and solve the problem is kind of the mantra that I'm after.
Yeah, app loader, maybe. I don't know. How does this compare to Ivy? I don't know if it's a hot take.
No, that's a good one. So Ivy was, so if you go even further back, about 3 years ago on NGConf, on the keynote, I gave a talk that basically describes Qwik right there. I was just like, we need to do this. We need to do this, right? And then nothing happens. Like, I gave the keys to the kingdom and nobody did anything.
I mean, what are you talking about? You're on the team. Like,
I mean, like the community, nothing in the community, nobody in the outside world be like, that's a good idea, we should do this, and like, let's solve it, or let's attack this problem. Like, nothing happened in the community. Now, internally, Ivy was a stepping stone to give us that capability so that we can do all of these things. And I think Ivy, in that sense, was kind of a success. The numbers I'm hearing from my friends saying how they're saving ridiculous amounts of CPU at Google just because how more efficient Ivy is on compilation, and also on a runtime CPU, and how much more productive the engineers are because their turnaround time for their applications are quicker, and so on. So in all of those measures, Ivy was a success. But I had a hope for Ivy that Ivy could be a stepping stone for this lazy loading technology. Yeah. But now that I fully understand the nuances of it all, it turns out there's no real way to do it, again, without introducing such significant breaking changes that it will be unpalatable to existing customers, right? And that is the crux of the problem. Like, at the end of the day, you have to write your code differently. You cannot nest, 20 closures on top of each other and then expect a sufficiently smart compiler to detangle that stuff. Not gonna happen, right? So instead, you need to provide guided rails for the developers so that they can appear as if they're nesting 20 closures on top of each other, but they're actually not, so that the tooling can come, separate all this stuff out, break it all up, and do all this magic. And on top of that, it has to be done in a way that is resumable rather than replayable, right? Because even if you can have a sufficiently complex compiler for React that separates all this stuff out, it still wouldn't help you, because in order for the React to figure out where the listeners are, React has to execute all of this code, right? And so even if you had this, you still wouldn't solve the problem.
Yeah. Yeah. Cool. Well, that's kind of what we planned talking web dev wise. I thought that was really cool meeting you, sharing about what you're.
Sorry if I got too excited. It's
No, I think your enthusiasm is just amazing. Honestly, like if I made Angular and I spent like 10 years, I don't know, was it 10 years?
It's been over 10 years,
yeah. I would just be done. I would just be like, hey, let someone else do this. But you're still in it. You're still like iterating on feedback that people gave you 2 weeks ago, and it's just amazing to watch. And so I hope that people are at least inspired to push the boundaries as much as you do. So yeah, I think that's really cool. Okay, so final question, which I'm trying to implement right now. If you were asked to give a TED Talk about something that you're not well known for, what would it be?
So my friends oftentimes get annoyed because all I talk about, I don't talk about computers. There's another topic that I talk about, and that is the metabolic health.
Let's do it. Yeah.
And my friends are annoyed with me because like it's all I'm talking about. And I have crazy opinions on this particular topic. Anyways, metabolic health it has a lot of different names, right? But it is the root cause to obesity, to cancers, to many different things. And it is one of those things that people just ignore and don't worry about, right? I was just saying how I went to Europe, to JAR, to the conference, and everybody was in great shape, etc. And then I was getting back on a plane to the US, where only US citizens are allowed to fly back right now because of the COVID, right?
Yes.
The whole line was a bunch of metabolically unfit people. It was insane. Like I just spent a week in Europe where everybody was fit and in the beach and
everyone's hot.
Whatever.
Yeah, everyone's hot.
And then you go back and you go like, what are we doing wrong here?
Can you define it? What do you mean? Is it different from regular health? What is metabolic health?
So long time ago, when we were single cell organisms, it was a symbiotic relationship formed between the main cell and a symbiotic cell, which became the mitochondria. And mitochondria has a separate DNA. It has circular DNA. Like our DNA is like this complicated thing that is rolled up, right? Mitochondria has circular DNA, just like a bacteria does. And so it looks like somewhere along the line, we consumed the bacteria, and that bacteria took permanent residence inside our cells. And what this particular bacteria is really, really good at is breaking down energy, whether it comes in the form of carbohydrate, alcohol, fats, and there's lots and lots of different fats, whatever thing you have that you can get energy at, mitochondria is really good on chewing down on that thing and spitting out this other thing outside called ATP, adenosine triphosphate. And all of the cellular mechanisms, or all the enzymes, everything on our body, and all the machinery that we have runs on ATP, right? So you can think of this as the mitochondria as the ATP generator. Turns out mitochondria can get sick by feeding it the wrong kind of fat, feeding it too much alcohol, feeding it too much sugars, fructose, all kinds of other things. And when the mitochondria get sick, bad things happen. And they end up being everything from high blood pressure to insulin resistance, type 2 diabetes, to being overweight, and it all basically goes back down to this crazy mitochondria.
Interesting. So how does that affect your diet? Like, is it mainly diet? Is it some exercise, or is it?
So my take on this particular problem is that anything that will improve insulin resistance is going to be better, right? So if you change your diet and you improve insulin resistance, that's going to be better. Certainly exercise improves insulin resistance. So exercise certainly helps. However, as people are fond of saying, is you cannot outrun a bad diet. Like, I think diet is like 80% and exercise is 20%. I'm not dismissing exercise. By all means, I go to the gym every morning and I wake up and go to my garage and I lift weights because I think it's important and healthy, right? But if I don't get my diet under control, any possible gain I can get out of weightlifting is going to be destroyed by crappy diet.
What rules do you have for dieting? Like, or not dieting, but more just general beliefs?
Yeah, so I avoid everything that spikes insulin. So people usually call it the ketogenic diet.
Yeah, high GI foods.
Yeah. So, but I like go to the extreme and I just like avoid everything that could basically, if it has carbs, I don't want it.
Yeah.
But more importantly than carbs is seed oils. So seed oils are, I think, the thing that messes up your mitochondria. And once the mitochondria is messed up, then a normal load of carbohydrate that normally mitochondria wouldn't have a problem with becomes a problem.
Sesame oil?
Yes. So I don't do that. That's crazy.
Oh my
Corn
God.
oil, soybean oil, like all this other stuff. Go online.
How do you cook? You don't know oil.
Hard. I eat lots of fat. I just don't eat seed oils.
Okay. Sorry. You said go online and go where?
Go online and Google how seed oils are manufactured. There's a good one by, how it's made, or how it's made. One of those things on Discovery Channel. Have you seen those things?
No, but I'll look it up.
It has nothing to do with health and anything. It's just purely like they go to random factories and they show you how this is made, how that's made. And so there's one that talks about like how seed oils are made. It is this insane process because there's like crazy chemicals. They have to dissolve it, raise the temperature, lower it. Then it stinks so bad nobody would drink it. So they have to purify it and bleach it. And then it has no color. So they have to add color to it. It's like, what? Like, how can this possibly be good for you?
It tastes good. That's all I know. But okay. All right.
Because we put stuff in it to make it taste good because it's flavorless, right? Because we bleached it before then. So, like originally it was such bad smelling thing that we had to bleach it to get the smells out of it and make it white. And then we have to add food coloring to it to make it yellow. And then we have to add any kind of flavoring into it so that it actually is palatable. It's like, what are you doing? Like, and the craziest thing is that somehow we convinced ourselves that that's healthy.
Yeah, I don't know if we've convinced, like, it's just normal. That's all. That's how I learned how to cook, so.
I've noticed, so the way I noticed this interesting thing, which is that when I was in Google, I would have breakfast every morning and I would have a bunch of eggs because I loved eggs. And I would feel miserable after the breakfast. And I would be like, I'm going to sluggish. Oh, this is just, and naturally people are like, oh, must be the eggs because the meat and the animal products are bad for you, right? And then I went to Mexico and I had a whole bunch of eggs on a vacation and I had a whole bunch of eggs and I was like, fine. I was like, nothing wrong with it. And I'm like, what's the difference? Huh. It's the same egg. What else is the difference? The difference is in Mexico, they were using lard to cook my eggs on. Whereas in Google, they used oat bran oil, right? And then I did a whole bunch of experiments at home and I realized, oh my gosh, it's the freaking oil that makes me feel miserable. And then you slowly kind of realize it's just the seed oils that are doing this. And if you read a bunch of literature, it turns out other people have come to the same exact conclusion that seed oils are a problem. And seed oils are super high in omega-6, and it turns out omega-6 it incorporates itself into the membranes of cells and makes the membranes not flexible, makes them stiff. And that kind of messes up mitochondria, and then mitochondria has troubles, and then all hell breaks loose.
Oh man. Okay. I gotta change it.
So it's a poison that will poison you over like 2 decades.
Jesus. All right. Well, cool. Well, I think that might actually save some lives today.
Or people will think I'm crazy.
So I think you're basically for lighter JavaScript and lighter body. So this is
yes,
great. Cool. Yeah. Thanks so much for joining me on this chat. And I learned so much today. Thanks so much.
Thanks for having me, man. This was so much fun.